Hi there everyone. In this video we're going to look at the electrophilic substitution mechanism for the acylation of benzene. Now the acylation of benzene is known as one of the Friedel-Crafts reactions. That's a reaction that was discovered by two men, one man named Friedel and the other one named Crafts. And there's two kinds of these types of reactions. One of them's acylation, where this acyl group is added onto a benzene ring, and the other one is alkylation, which I'll show in a future video. So I've written the overall equation at the top, and we've got benzene reacting with ethanoyl chloride, also known as acetyl chloride, that's its common name, to give phenylethanone, otherwise known as acetophenone, and hydrogen chloride. The electrophile for this mechanism is the acetyl cation, and that is formed from the ethanol chloride reacting with the aluminium chloride. And what happens is the aluminium chloride picks up this chlorine, which forms the electrophile, and the aluminium chloride anion. So the generation of the electrophile starts the reaction, and two electrons from the benzene ring, this delocalized system, move to form a bond with the carbon of this electrophile, and this results in a positively charged intermediate with a partially broken ring system. Now this is when the aluminium chloride anion, the negative ion that was formed here at the same time as the electrophile, that comes in and picks up this hydrogen, which was already bonded to the ring. We just didn't show it because this is a type of skeletal formula. So one of these aluminium chlorine bonds breaks, the electrons from the bond move to the hydrogen, and we end up forming hydrogen chloride as a byproduct, and this causes the carbon hydrogen bond to break, and the electrons from that bond move to go and reform this delocalized ring system here. So the ring's restored in the product, and this product is a ketone called phenylethanone.